to After Effects classes. In this video I will continue infinite series topic. Next method I will discuss, that is Cauchy's integral test. If ux is non-negative, non-negative means positive, integral and monotonically decreasing function such that un is equal to u of n is equal to un, then if infinite integration of 1 u of x dx converges, then the series sigma infinite n is equal to 1 un also converges. For example, we have given sigma infinite n is equal to 1 over n square 1. This is statement is given, and we have to implement Cauchy's integral test for convergence. First of all, as it you have to take un is equal to 1 over n square plus 1. Then let un, then let u of n, u of x equal to 1 over x square plus 1. It means you will take here, instead of n we will take here x. U of x is non-negative. Integrable. And monotonically decreasing function. Now consider infinite integration 1 over x square plus 1 d of x is equal to, that is equal to 1 over that is equal to tan inverse x 1 by 1 over x square plus 1. Its integration will be equal to tan inverse x, and these are given limits, and these limits will be written here, infinite and 1. Now solve it. Tan inverse x is infinite minus tan inverse, instead of x we will substitute 1, and tan inverse infinite, that is equal to pi over 2, and tan inverse 1, that is equal to pi over 4. when we take LCM, 2 pi minus pi, that is equal to pi over 4, and pi over 4 which is finite, hence infinite integration 1 over x square plus 1 derivative of x, that is converges. So sigma infinite n is equal to 1 1 over n square plus 1 also converges. How to solve this? First you have to put first of all you have to put un is equal to that statement which is given in your question, 1 by n square plus 1. After that let ux is equal to 1 over n's value substitute x square plus 1, and u of x is a non-negative and integrable and monotonically decreasing function, and after that you have to write integration infinite integration 1 over x square plus 1 derivative x, and take the integration. Its integration is equal to, according to formula, tan inverse x, and limit is infinite and 1, lower limit is 1 and upper limit is infinite, and after substituting these limits in value tan inverse x, we will find out pi over 4, that is finite, and because it is a finite, so it is a converges, so we can say sigma infinite n equal to 1 over n square plus 1 also converges. Now I am going to discuss next method, that is Leibniz test. Leibniz test. In Leibniz test, we will implement alternating test. The alternating series. Alternating series sigma infinite n is equal to 1 minus 1 whole power minus n minus 1 un converges if it satisfies the following conditions. First is un plus 1 is less than equal to un, and second one, limit n is to infinite un equal to 0. We will take one question for implementing this formula. I will take here one question, that is related to 1 minus 1 by 2 plus 1 by 3 plus minus 1 by 4 plus, first of all write the given series in which format is given. The given series is sigma infinite n is equal to 1 minus 1 raised to power n minus 1 into 1 by n. Here un that is equal to 1 by n, because 1 by n plus 1, because 1 by n plus 1 is less than 1 by n, so u plus n plus 1 is also less than equal to un. And also limit n is to infinite un that is equal to limit n is to infinite 1 by n that is equal to 0, and hence by Leibniz test the given series converges. Now next convergence is absolute convergence. A series sigma infinite n is equal to 1 un is absolutely convergent if the series sigma infinite n is equal to 1 modulus of un is convergent. If this is convergent, then we can say it is also absolute convergent. For example, we have given sigma infinite n is equal to 1. This is example. Un is equal to 1 minus 1 by 2 plus 1 by 2 raised to power 2 minus 1 by 2 raised to power 3 plus this is absolutely convergent as sigma infinite n is equal to 1 modulus of un that is equal to 1 plus 1 by 2 plus 2 raised to power 2 plus 1 by 2 raised to power 3 up to is a convergent series because it is a geometric series whose common ratio is 1 by 2, that is less than 1. So every absolutely convergent series is convergent, but the converse may not be true. Now next convergence is conditional convergence. A series a series which is convergent but not absolutely not absolutely convergent is called conditional, or you can say conditionally convergent series. Example, you have given 1 minus 1 by 2 raised to power 2 plus 1 by 1 plus 1 by 3 raised to power 2 minus 1 by 4 raised to power 2 plus, this statement is given and you have to prove. First of all, write the given series sigma infinite n is equal to 1 minus, sorry, here we have to write n is equal to 2. Just a minute, here also write no, it's correct, it's 1, but in this case you have to write here n is equal to 2 minus 1's whole power n plus 1 un. Here un is equal to 1 over log n. Now log x is an increasing function for all x is greater than 0. So log n plus 2 is n plus 2 is greater than log n plus 1, or you can say 1 by log n plus 2 is less than 1 by log n plus 1. So u n plus 1 is less than equal to un. Also limit n is to infinite un is equal to limit n is to infinite 1 by log n, that should be equal to 0. Hence Leibniz test, the given series is convergent. Now for absolute convergence, consider sigma infinite n is equal to 1 modulus of un equal to sigma infinite n is equal to 1 over log n. It is divergent series hence given series is not absolutely convergent. And this is example of conditionally convergent series. Now, next topic is expansion of functions. Expansion of functions, in which we will discuss Taylor's series. If a function fx is infinitely differentiable at the point a, then you can say function of x can be expanded about the point is as function of x that is equal to function of a plus x minus a f dash of a plus x minus a's whole square over 2 factorial f dash dash a plus x minus a whole cube over 3 factorial f dash dash a plus up to plus x minus a's whole power n over n factorial f n into a plus, and also you can say f of a plus h, where h is small, can be expanded as f of a plus h, f a plus h f dash a plus h square over 2 factorial f dash dash a plus h cube over 3 factorial f dash dash a plus up to plus h raised to power n over n factorial f dash f n a plus this series. This is your Taylor's series. Now next series is MLAURINS Mollrin series. It is the special case. It is the special case of Taylor series about the point 0. Hence, the Malrins Malaurin series of fx is f of x is equal to f of 0 plus x f of dash 0 plus x square over 2 factorial f of dash 0 plus x square x cube over 3 factorial f dash of 0 plus up to plus x raised to power n over n factorial into f n into 0 plus. And there are some standard functions which are given in Malrins series. Standard functions, you should be keep in mind these functions. First function is sine x, that should be equal to x minus x raised to power cube 3 factorial plus x raised to power 5, here 5 factorial minus x raised to power 7 factorial. Second one is cos x, that should be equal to 1 minus x raised to power 2 over 2 factorial plus x raised to power 4 factorial minus x raised to power 6 over 6 factorial. Sin x is equal to according to odd numbers and cos x is equal to according to even numbers. Now third standard function is e raised to power x, that should be equal to 1 plus x raised to power 2 over 2 factorial plus x raised to power 3 over 3 factorial x raised to power 4 over 4 factorial. If this is given, this type of series is given, that should be equal to e raised to power x. And fourth is log 1 plus x, that should be equal to x minus x raised to power 2 factorial plus there is no 2 factorial, only 2, x raised to power 3 over 3, then minus x raised to power 4 over 4 up to comma modulus of x, that should be less than 1, and log 1 minus x, that should be equal to minus x square over 2 minus x raised to power 3 over 3 minus x raised to power 4 over 4 minus up to series. And next 1 plus x raised to power m, that is equal to 1 plus mx plus m minus 1 over 2 factorial x raised to power 2 plus m minus 1 m minus 2 over 3 factorial and into x raised to power 3, and this series will be continued. Now I am taking one question for implementing these series. For example, we have given question like this: expand tan x in powers of x minus pi over 4 up to first 4 terms. How to solve it? First of all, we use Taylor's expansion method. function of x, that is equal to function of a plus x minus a f dash a plus x minus a whole square over 2 factorial into f dash a plus x minus a whole cube over 3 factorial f dash a plus, this is your first equation. Now function of x is equal to, that is tan x, which is given, and a is equal to pi over 4. It is taken from question. Now function of pi of 4 equal to tan pi over 4, that should be equal to 1. After that, pi dash of x, that is equal to secant square x, f dash pi over 4 secant square pi over 4, that is equal to 2. After that, again next function of function x, 2 secant square x tan x, and its function of function pi over 4, when we substitute x value pi over 4, then we find that is 4. Again next, again its function, that should be 2 secant power 4x plus 4 tan square x secant square x, and when we solved it by substituting pi over 4, 2 secant power 4 pi over 4 plus 4 tan square pi over 4 secant square pi over 4. After that, when we solved, it will be equal to 16. Now putting these values in equation 1, tan x is equal to 1 plus 2x minus pi over 4 plus 2x minus pi over 4 whole square plus 8 over 3 x minus pi over 4 whole cube, and you will find your final answer. Now this is your last topic, that is approximate error. What is approximate error? Let y be a function. Let y be a function of x, that is y is equal to function of x. If delta x is a small change in x, then resulting change in y is denoted by delta y, and is given by this way. Delta y is equal to dy over dx delta x approximately. One question I am going to solve. Find the change in total surface area of right circular cone when, first point, the radius is constant. The radius is constant, but there is a small change. There is a small change in the altitude. Second, the altitude is constant, but there is small change in the radius. How to solve it? First of all, suppose let radius of a base is r and altitude of a base is h. The change in the altitude is altitude b, radius is constant, but there is small change. There is small change in the altitude, that is delta h. So suppose SB, the total surface area of the cone. Then S is equal to pi r square plus pi r in square root r square plus h square. In first, according to first point, if altitude changes, then delta S is equal to ds over dh delta h. Now ds over dh, that is equal to 0 plus pi r over 2 r square plus h square whole power minus 1 by 2 into 2h, and that is equal to pi r h over in square root r square plus h square. So delta S is equal to ds over dh delta H is equal to pi r h over in square root r square plus h square into delta H approximately. And according to second point, if radius changes, then delta S is equal to ds over dr. Delta r. Now ds over dr is equal to 2 pi r plus pi square root r square plus h square. This is the formula. 2 pi r square over 2 root r square plus h square, and that is equal to 2 pi r plus pi is common and 2r square plus h square over r square plus h square square root. So delta S is equal to ds over dr. Delta r is equal to 2 pi r plus pi to r square plus h square over in square root r square plus h square into delta r approximately. This is the last topic. In 3 videos, I have discussed these points. First, series, sequences. Then I have discussed what is convergent sequence. After that, I discuss divergent sequence. And in series, I have discussed about infinite series. After that, I have discussed positive term series, that is known as P series. After that, necessary condition for convergence. Then I have discussed tests. First, comparison test. Then limit form test. Then D, then D's Elm-Burt's ratio test. Then Rab's test. Cauchy's test. Cauchy's integral test, logarithmic test, Leibniz test, absolute convergence, then conditional convergence, then Taylor's series, Malaurin's test, series, and last, approximate error. I have tried to teach you all these tests in 3 videos. If you like these videos, please like and share my channel with your friends so that they can take benefits from these videos. And don't be forget to subscribe my channel next upcoming videos. Like and share. Always keep smiling.